Good morning. Today we're going to talk about radicals and simplifying radicals. Somewhere around here. This is a unit on radicals. So let's go ahead and get started. The first thing we're going to talk to you about is simplifying radicals using the product rule. We want to write the square root of 60 in its simplest form. So I'm going to go through this slowly, and I'm going to do it with you at least a couple of times. The symbol around 60 or above 60 is called a radical or a square root sign. The first thing we want to do is we want to prime factor 60 to make it simpler so that we can simplify the radical. Please remember, a prime number is any number that only has factors of 1 in itself. So we're just going to take it over here for a minute, and we're going to look at radical 60. So basically, you can prime factor it as 2 times 30. You can prime factor 30 as 3 times 10. And you can prime factor 10 as 2 times 5. Are you with me? So if we wanted to write the prime factors of radical 60, it would be 2 times 2 times 3 times 5. Okay, so let me ask a question. How many of you, when you were growing up, ever played that game, Go Fish? Remember you had to get pairs, and every time you got a pair, you put the cards down. Okay, so what we're looking for here is we're looking for pairs. Do you see any pairs under the radical sign? Good. We see a pair of what, guys? A pair of 2s. Okay. Listen to what I'm about to say. For every pair that is circled, one of those numbers comes out. Let me explain to you why. 2 times 2, or 2 squared, equals what? 4. What's the square root of 4? 2. So we're going to take a 2 outside of the radical. The 3 and the 5 don't have any pairs. 3 is not paired with another 3. 5 is not paired with another 5. So they stay under the radical. And your final answer here is 2 radical 15. Or we could read it as 2 square roots of 15. So let's take a look back at the notes that you have in front of you. I want to go through it one more time. Okay? Breaking up the problem into multiple radicals makes it easier to simplify. So you saw I did this step right here. The square root of 2 times 2 times 3 times 5. I circled the 2's. A lot of times the books are going to write it as 2 squared, which we know is 4, and the square root of 2 squared is 2. So that's another way, whichever way works best for you, whichever way your brain comprehends is correct. They're both correct, and the answer is 2 radical 15. So let's just go ahead and go through it one more time. Again, I broke this down for you really into a lot of baby steps. Step number 1. Find the prime factorization of the number underneath the radical. Write out the prime factorization of 60. It will make it easy to simplify the radical. Again, it explains what a prime number is. You should all know what a prime number is. Rewrite the factors. You can use exponents if you like. So again, instead of writing it as 2 times 2 times 3 times 5, we could write it as 2 squared times 3 times 5. Okay, anybody have a question? Anybody have a question? All right, let's go ahead and let's try another one. So let's try another example. Let's try this one together. Example. Let's simplify radical 28. So the name of the game is you're going to simplify the radical, and we cannot leave any perfect squares underneath the radical sign. So let's prime factor it. Who can prime factor 28 for me? Breaks down to what?
7 and 4.
7 and 4. 7 is prime. 4 breaks down to what? 2 and 2. So this would break down to 2 times 2 times 7. Or, if you know your final answer, you can go ahead and write it at this time. I just want you to think. I'm going to give you an analogy. This might help. So because I have a pair of 2's, which is the same thing as the square root of 2 squared times 7. Whoever can come out of, we're going to think of the radical sign as prison. They're in jail. And your job is to let out as many people or as many numbers from jail as possible. So the square root of 2 squared times 7. Who's coming out of prison, guys? 2. Who's staying in prison, guys? And your answer is 2 radical 7. How many people got 2 radical 7? Good. All right, let's try something a little non-conventional. The square root of 25. The square root of 25. Now I'm going to give you a major hint. If you know that something is already a perfect square, you do not have to go through the process of prime factoring it. So hopefully you would all catch 25 is a perfect square. I don't really need to do anything. The square root of 25 is 5. If you didn't catch it, then you would break it down to prime factorization, and you could rewrite it as the square root of 5 times 5, or the square root of 25 equals 5. Are you with me? Are you sure? Okay. All right. Let me go on to looking at the second method with you. I will tell you where we are in a minute. Just give me a second here. Okay, what your objectives are would be that you'll be able to simplify a radical expression, apply those skills for simplifying radicals and solving second degree equations. We're not going to be solving any equations at this time. Again, the number or the whatever is underneath the radical sign is called the radicand. So what's ever under the square root sign, so we're going to highlight a few things so you have some terminology. The item underneath the radical sign is called the radicand. So in the square root of 5ab, 5ab is the radicand. Items under a radical symbol can be multiplied or divided. And as far as we're concerned, in Algebra 1, the radicand cannot be negative. You deal with that in Algebra 2. They're called imaginary numbers. We do not deal with that at this time. Okay, the radicand, or what's under the radical, cannot contain any perfect squares. The radicand cannot be a fraction. So you can't have fractions. You can't leave perfect squares. You can't leave a negative number. Okay? And you cannot have a radical in the denominator. Okay? We want to be sure that we know our perfect squares. You can make a list of them. They left 1 out: 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, and so on. Okay? All right. Let me go ahead and just take a minute over here to do one more with you using and simplifying radicals by prime factorization. And then I'm going to show you the other method as well. So we want to simplify. Let's try a couple. Radical 72. Radical 72. So let's everybody go ahead and prime factor radical 72. Who wants to help me out? 72. Name 2 factors. Go. 9 and 8. And what does 9 break down to? 3 and 3, and they're both prime. What does 8 break down to?
4 and 4.
2 and 4, and 4 breaks down to 2 and 2. So radical 72 would be 2 2s, 3 2s, and 2 3s. Is that correct?
Yes.
Okay. So if we want to find our pairs here, I think you can see you have 1 pair of 2s, correct?
Yes.
And 1 pair of 3s. This is a good problem. Stay with me and pay attention. You have a pair of 2s and a pair of 3s. So who's coming out of prison? 1 2 and 1 3. Whoever comes out, you're going to multiply them together. So we have 2 times 3, radical 2. Our final answer would be what? 6 radical 2. Good job. Multiply if more than one number comes out. Let's try another one. How about radical 48? Radical 48. Everybody go ahead and prime factor 48. I can't hear you. 6 and 8. Good job. Everybody break down 6. 2 and 3. 8. 2 and 4. 4. 2 and 2. Okay, I'll let you guys give me a final answer when you have it. Good job. Good job. Rachel, what'd you get? 4 radical 3. How many people got 4 radical 3? Anybody have a question? Can you grab me a set of notes from the back, please? Thanks. All right, here we go. Let's add something else to the mix. Let me tell you what page I'm on in your notes. I'm just going to add a couple of things in. We are going to cover it later on Friday, but I just want to give you an opportunity here to just show you the second method. The second method is using perfect squares. 5 perfect squares. This may be actually in the second part of your notes, which is unfortunately right now going in an opposite direction. So let me give you a page number if I can. And there should be stuff on fronts and on backs. If you go to page 25 in your notes, okay. We're going to go ahead and we're going to work these problems both ways. Method 1. Method 1 is prime factorization. Method 2 is perfect squares. Okay, so let's go ahead and simplify radical 8. Radical 8. Does everybody have your perfect square sheet in front of you? It's in your notes as well. Did you all see where I listed them for you in your notes? Yes? Do you want me to give you the page number again? Yes, please? You got it. No problem. Your perfect squares are on page 5. 4, 9, 16, 25. Okay? You with me? Yes? All right. So what you need to do, if we want to find the perfect square method, again, we're not using calculators. You need to decide what's the biggest perfect square in 8. 4. So this would break down to radical 4 times radical 2. And we all know that radical 4 equals what? 2. So your answer would be 2 radical 2. The other method, guys, look at me. You don't have to use both. You need to use the one that works best for you. Radical 8 would break down to, if you're going to prime factor it, 2 times 4. 4 breaks down to 2 times 2, and you get 2 times 2 times 2. Final answer, what do you get, guys? 2 radical 2. Okay, this next one, I want you to try by perfect squares. Everybody simplify radical 20 by using perfect squares. So look back at your perfect square sheet and find the biggest perfect square in 20. Joseph, what is it? Okay, so square root of 20 would break down to the square root of 4 times the square root of 5, or your final answer would be what, guys? 2 radical 5. If we were going to do it using prime factorization, you're going to get the same answer, guys. It's just a personal preference on which method you prefer. I'm going to be honest with you. I think right now for you guys, I think prime factorization is the easiest. How many people agree that prime factorization is the easiest? Okay. How many people like finding the perfect square? Okay, so you can do that. You just need to realize that when you're done, you need to always look underneath the radical and you need to say, are there any other perfect squares? Because that could keep you from getting a right answer. So I'm going to go ahead and resume teaching it by using prime factorization. Let's add something into it. So let's add another example in here. Let's make it the square root of 40 x squared y cubed. So now watch what happens when I go to prime factor this. 2 times 2 times 2 times 5 times x times y times y times y. So now I'm looking for what? Looking for pairs because I'm playing the game what? Go fish. I have a pair of 2's, I have a pair of x's, and I have a pair of y's. So one of each of those comes out. I have a 2, x, and a y that comes out of prison. Who stays in? 2 times 5 times y for what? 10y. Now you can always look here and ask yourself a question, Kylan. You can ask yourself, does 10 have any perfect squares in it? And you know it doesn't because 10 only breaks down to 2 times 5. This tells you that you factored this correctly. Now I want to just go on record as saying that you're going to see in a lot of textbooks and a lot of literature and even in these notes later on over the next couple of days, guys, look and listen, you're going to see stuff like this. They're going to tell you that the square root of x squared is the absolute value of x. It is not necessary to put the absolute value symbols in. Did everybody just hear me? Actually, I don't think any of us in the math department hold you responsible for that at this time in Algebra 1 geometry or Algebra 2. Do you remember, Chris, did they make you use the absolute value when you were taking the square root of x squared? Maybe in Algebra 2 honors? Yeah. In Algebra 2 honors. So we're going to wait until we get there because right now we're learning and I think we're doing a great job. Okay, does anybody have a question up to this point? That was pretty simple and straightforward, correct? All right, let me just check one thing for you. And for those of you listening online, this is only a very brief introduction into what we're going to do. We have lots more to do. So we hope you have a great day, and thanks for listening. Okay, let me just go on.